Imagine waking up to a sunrise on Mars. The sky glows a dusty orange, and instead of birds chirping, the hum of life support systems fills the air. You step out of your habitat, and in the distance, a fleet of rovers crawls across the red landscape. This isn't science fiction. It's a future that might be closer than we think. For decades, humans have dreamed of living beyond. Now, with private companies and space agencies racing to build the first permanent off-world settlements, that dream is turning into reality. From space stations orbiting Earth to colonies on the Moon and Mars, engineers and scientists are designing habitats that could sustain human life in the most extreme environments. But how will we actually live in space? What will our homes look like? And what challenges stand in the way? Today, we're diving into the future of space habitats. What's possible, what's in development, and what might still be just beyond our reach. Before we jump into the future, humans have always been explorers, pushing boundaries, crossing oceans, and climbing mountains. But space, that's the final frontier, the most extreme, unforgiving environment we've ever tried to conquer. The idea of living in space isn't new. In fact, it's been around for over a century. Early science fiction writers imagined vast space stations and floating cities orbiting the Earth. But turning that dream into reality, that took science, engineering, and a whole lot of bravery. The first real step towards space habitats happened in 1971. The Soviet Union launched Salyut 1, the world's first space station. It wasn't much, just a small cylindrical module floating in orbit. But it proved that humans could survive for extended periods in space. Unfortunately, the mission ended in tragedy. The returning cosmonauts perished due to cabin depressurization, a stark reminder that space is deadly. A few years later, NASA responded with Skylab, a repurposed section of a Saturn V rocket that became America's first space station. It had living quarters, a workshop, and even a solar observatory. Astronauts stayed for months, testing how the human body adapted to microgravity. But Skylab was temporary. Without a way to boost its orbit, it eventually fell back to Earth in 1979, breaking apart over the Indian Ocean and Australia. Then came the real game changer, the International Space Station, ISS. Launched in 1998, the ISS isn't just a research lab, it's a home. With contributions from NASA, Roscosmos, JAXA, ESA, and CSA, it became the largest human-made structure in space. Astronauts from around the world have lived and worked there continuously since 2000, conducting groundbreaking experiments and proving that long-term space habitation is possible. The ISS taught us invaluable lessons about life in space. We figured out how to recycle water, grow plants, and exercise to counteract muscle loss. But it also showed us the challenges: radiation exposure, psychological stress, and the sheer cost of keeping people alive in orbit. So where do we go from here? The ISS won't last forever. It's set to be decommissioned by the 2030s. But the knowledge we've gained is paving the way for the next generation of space habitats, ones that could take us beyond Earth's orbit to the Moon, Mars, and beyond. That brings us to today's big question. What will the space homes of the future actually look like? Let's find out. So, we know humans can survive in space for a while, but a cramped tin can-like station isn't exactly a long-term solution. If we want to settle space for good, we need something bigger, smarter, and built to last. Scientists and engineers have been working on that problem for decades, and some of their ideas? They're straight out of science fiction. O'Neill cylinders, rotating cities in space. In the 1970s, physicist Gerard K. O'Neill asked a bold question. Why settle for small space stations when we could build entire space cities? His answer? The O'Neill cylinder, a massive rotating habitat designed to house millions of people. Picture this, a giant tube, 5 miles wide and 20 miles long, spinning in space to create artificial gravity. Inside, there are cities, rivers, forests, even simulated weather. Sunlight reflects off enormous mirrors, creating a natural day-night cycle. It's Earth, but in space. Sounds ambitious, right? It is. Right now, The materials and energy needed to build something like this are way beyond what we can manage. But with asteroid mining and advancements in space construction, O'Neill-style colonies might not be impossible in the distant future. Stanford Torus, a ring-shaped space. Home. If O'Neill cylinders are too massive to build anytime soon, how about something a little smaller? Enter the Stanford Torus, a ring-shaped space station about a mile in diameter, rotating to generate Earth-like gravity. Think of it as a giant spinning wheel with homes, farms, and parks built on the inside. NASA first explored this design in the 1970s as part of a study on space colonization. The advantage? It's more realistic than an O'Neill cylinder, still huge, but easier to build with today's technology. Plus, it solves one of the biggest issues with living in space: gravity. Long-term weightlessness weakens bones and muscles. By spinning, a torus would create 1 g of artificial gravity, just like Earth. The downside? Radiation. Without a planet's magnetic field, space habitats need serious shielding to protect against cosmic rays. That means either thick walls of regolith, space dirt, or an electromagnetic shield, both of which are still being developed. Lunar and Martian habitats. Living on other worlds. Maybe the best place for a space habitat isn't in space. Instead of floating cities, some scientists argue we should settle on the Moon or Mars first. The Moon is the logical first step. It's only 3 days away, meaning resupply missions are possible. Plus, there's water ice at the poles, perfect for drinking water and making rocket fuel. NASA's Artemis program plans to set up a permanent moon base by the 2030s, using 3D printed structures made from lunar dust. Then there's Mars. It has an atmosphere, though thin and toxic, lower gravity, and plenty of space to expand. But the distance is a problem. It takes 6 to 9 months to get there. Once you arrive, there's no quick return. That's why Mars bases will need underground shelters or inflatable habitats covered in thick layers of soil to block radiation. Elon Musk's SpaceX envisions a self-sustaining Mars colony with a fleet of starships ferrying people and supplies. But getting there is only half the challenge. Making it livable is another story. Asteroid habitats, turning space rocks into homes. Here's a wild idea. Instead of building space habitats from scratch, why not use asteroids? Some scientists propose hollowing out large asteroids and turning them into natural space stations. The rock itself would provide radiation shielding, and if it's big enough, we could even spin it to create artificial gravity inside. This concept, called Bernal spheres, suggests that near-Earth asteroids could become ready-made homes with enough space for thousands of people. The biggest challenge? Mining and hollowing out an asteroid without breaking it apart. We're still figuring that one out. Some experts believe that the key is reducing launch costs. The cheaper it is to send materials and people into space, the more realistic large-scale habitats become. Reusable rockets, 3D printing, and using local resources like lunar ice and Martian soil will be game changers. Bottom line, the dream of living in space is no longer just science fiction. From small research stations to massive rotating space cities, the pieces are starting to come together. Governments, private companies, and scientists worldwide are pushing the limits of technology to make space habitats a reality. In the next 10 to 20 years, we'll likely see a permanent moon base, commercial space stations, and maybe even the first steps toward a Mars colony. Within 50 years, rotating habitats like the Stanford Torus or Bernal spheres could begin construction, providing long-term homes for humans beyond Earth. If asteroid mining and space manufacturing take off, we might even see the beginnings of fully self-sustaining space cities. But this isn't just about exploration, it's about survival. Earth won't be habitable forever. Climate change, overpopulation, and natural disasters all threaten our future. And in the distant future, asteroid impacts, supervolcanoes, or even the slow death of our sun will make staying on Earth impossible. The real question isn't if we should build space habitats, But when? Will we start now, expanding our reach beyond Earth while we still have time? Or will we wait until we have no other choice? One thing is certain. The first generations of space settlers are already being born. And whether it's on the Moon, Mars, or inside a spinning space station, the future of humanity may not be on Earth at all. So, where will we build our first true home in space? The answer might come sooner than we think. What do you think? Which space habitat excites you the most? Let us know in the comments below. And don't forget to like, share, and subscribe for more deep dives into the future of humanity in space.